Hello everyone. This is Ronit. I'm part of Coordinator team, and I will today discuss two questions which were asked in the Meta interview, and the questions are already on your screen. So, question one and question two. These were the two questions that were asked in a single virtual live interview of Meta, and I will be discussing the algorithm to solve those. Although they are medium questions, you can find them online, but I will still add, some of my understanding which can expand over whatever you find online, and also, give you some tips over how to write a code in a better and shorter way. So I will be coding in Java, but the questions algorithms are simple enough to modify in any language you want, and it should not at all be difficult. And everything in this session is recorded, and I've already messaged the link to my YouTube channel. You can subscribe to it, and I will be posting this recording within a week. And so you don't need to save code or worry about taking notes, so that you can always see the recording. So to keep it short, let's go over the question one. And like, if you have any ideas or anyone has any approach to solve the question one, which is like given a string s of lowercase characters, determine if you can make it a palindrome by removing at most one character. So if you have any thoughts or approaches just to, make it more interactive, you can message in the chat, and then I will explain an approach and code it in Java, and also code it in some somewhat different ways, show you some different style of coding and how you can use advanced features of Java like streams and Java 8 APIs to write a shorter code, which can actually save you time during uh, online assessments or even during virtual live interviews. So feel free to comment anything in the chat if you have any ideas. Otherwise, maybe in 1 or 2 minutes, I will start explaining the approach. And yeah, just share your comments in the chat. Question is there in the on the screen. You should be able to see the shared screen. I've shared the screen. Is everyone able to see the screen? Okay, cool. So you can just see the question is just about, so it's not a very difficult question. So given a string S, we have to determine whether we can remove at most one character from it and make it a palindrome. So it's like, if given a string, if it's a palindrome, then you should answer a boolean like true. So if it's a palindrome, then we can answer true. Otherwise, suppose the string is not palindrome. So I'm just breaking it down. Then is it possible to remove a single character from that string and make it a palindrome? If yes, then answer true. So we return. So if you write a Java function for it, we return true in two cases. One is if the string is already a palindrome, then we just return true. And if it's not a palindrome, then we try to figure out if there is a single character we can remove, that can, by removing it, the resulting string will become a palindrome. And if that's possible, then return true. And if none of these two things are possible, then you return false. So let's break this down further. So yeah, Ellen has mentioned something which is similar to the solution. So let's break this down. So I hope everyone understands the question. Otherwise, I will repeat it again. But as we go over the solution, I will just explain the solution first and then show you the code that I have written, and then we'll also go over how to write a shorter code and more concise and more readable code, which once you learn the ways to do that, it can really help you save the time and also show you your coding skills to the interviewer. Because companies like Meta, they not only look for your code, they also look for your approach, your time complexity, space complexity, and the way you code. So now the thing is, we want to, we have the option. So how do we do this? So just like I explained this, what I explained. So given a string s, if it's a palindrome, then I return true because the question asks for you can remove at most one character. Otherwise, if I can remove a single character from s and make the resulting string a palindrome, then return true, else return false. So one simple thing could be like given a string s and check if it's a palindrome, and uh, and if it's not a palindrome, then I can remove a single character from s and make the resulting string a palindrome. And now one way to do this would be just to write a simple function to check if a string is palindrome, and let's suppose our original function that we need to write is, if we want to check if the, so I'm writing in a pseudocode style. I will soon show you the exact Java code which I've already written to save time. And you don't need to take notes or save anything because all this recording will be pasted on my YouTube channel, which you can search by at the rate codeeducator or at youtube.com/codeeducator.com, youtube.com/codeeducator. So now I can write a function. Now if it's a palindrome, then obviously we can return true. But if it's not a palindrome, a very brute force. So initially, I'm just mentioning a brute force approach, which is not very efficient, but just for the sake of seeing how many different ways we can solve this question, and then we can see if we can remove a single character. So what we can do is, in general, if we follow what I have written above, we so there are, say, suppose n characters, and what I can do is fetch a string. This is just I'm writing in a pseudocode style. This is not Java functions, but just to explain the idea what this how this approach will look like. Because I won't be coding this approach because this is not an efficient approach. I will be telling you more efficient approach, and then we check. So if it's palindrome, then we return true. Otherwise, we return false. So writing a basic brute force approach like this can sometimes help you understand the question and make a first step towards the solution. So sometimes it's good to write a non-efficient solution. So this is just a very simple approach. If it's a palindrome, then we return true, and we can obviously implement this palindrome function. I will go in. That's not that difficult. And otherwise, I just loop over each of the characters and remove the character one by one and see if the resulting string is a palindrome. If it's a palindrome, then I return true. Otherwise, I return. Otherwise, I know that even after removing a single character, I cannot make the string a palindrome, and so I return false. Now let's analyze the time complexity of this. So to check if a string is palindrome, we need to actually iterate over the whole string because we need to compare the first and last character, and then we need to move the pointer from the beginning to the next character and the pointer that is in the last to the next character and check whether they are same or not. So in the worst case, we may have to traverse the whole string, and to check that if the string is palindrome, it will take order of n time, where n is the length of the string. So if you see here, I'm checking. So if n is the length of the string, that means this loop is running n times, and this check will again take n steps. So this algorithm takes order of n square time. So this is one neat and clean solution, brute force approach. Now I will. It's good sometimes to write a brute force approach to get more hold over the question, and sometimes you can write more test cases and then change your approach and then make the solution more efficient. So I will explain another approach which is much more efficient, and the time complexity of the below or new approach, we'll try to aim for the time complexity of order of n. So one simple observation that we can do if is that we can compare the first, we suppose we have a pointer to the first character of the string and the last character of the string. Now, if these two characters are not same, so again I'm repeating this. So there is a pointer to the first character of the string s and there is a pointer to the last character of the string s. Now, if these two characters are not the same, that means the string is certainly not a palindrome. Because if it was a palindrome, it must read the same from the left and the right. So if these two characters are not the same, that means we will have to remove at least one of these two characters. Either we remove the character on the left pointer on the left side, or we remove the character that's pointing on the right side to make it a palindrome. So what this approach is like, make two pointers, left and right, and initially left points to index 0 and right points to n minus 1, where n is the length of the string, and if char at, and if the character at f s dot left is equal to right, that means there is a possibility of that this string may be a palindrome. Or even, or what we can do, then we can check for the next two characters. So we can move the pointer forward. So that will be left plus plus and right minus minus. Now, if s left is not equal to s right, that means string is certainly not a palindrome. Now we have a choice to remove at most one character. And so we must remove either s left or s right to make it a palindrome. Because if we don't remove s left and s right, then since by the logic of palindrome, the character at the left and the right pointer must be same, this s left and s right are not same, so it won't be a palindrome. And by removing, unless we remove one of them, there is no possibility to make it a palindrome. So we have two options here: remove left, and case two, remove right. So what we can do if it's case one, so suppose this is our new string that we get by removing left and by removing right. Now one of these two strings, s dot remove s dot right. Now these are resulting string s2 after removing s2. Now we can check if this is a palindrome, or I can even write it in one line and remove this s2 just to avoid any confusion. Since we have to remove at least one of the left or right, and if and one of these, by removing this, the resulting string must become a palindrome. If this string is not a palindrome, if we remove the left character and the string is not a palindrome, and if we remove the right character and the string is not the palindrome, that means it doesn't matter whether you remove left or right, the string will not be able to be a palindrome. And since we can remove only at most one character, that means the string cannot be made a palindrome by removing at most one character. So if if this is not a palindrome and the right one is not a palindrome, that means we have tried removing one character and we cannot make it a palindrome, then we return false. Otherwise, one of them is a palindrome, and that means by removing one character exactly, we made it a palindrome, and so we can return true. So now, if you analyze the time complexity of this, what we are doing here, so we are just incrementing left and right pointer, and at most, what will happen, the we may not come to this part of the logic in case the string S is a palindrome, and in that case, we will just make order n steps And if we come to this part, then we'll remove this left character, one of these character, and check if this is a palindrome. So this will take order and time, and this will take order and time. So the time complexity of this approach is order n. So that's the difference between the time complexity of the brute force approach and this approach. Let me know if there is any confusion in the this particular approach, and you can just text me in the Google chat. Although this is a pretty straightforward idea. So basic logic is like if we get a two left and right characters which don't match, then to make it a palindrome, we will have to remove one of those, and we can try removing one of those and see if that's a palindrome. So remove left and see if it's a palindrome. If it's not a palindrome, then remove right and see if it's a palindrome. If it's not a palindrome, that means by removing left and or by removing right, still the string cannot be made a palindrome. And since we are allowed to only remove at most one character, that means the string cannot be made a palindrome by removing at most one character and we return false. Otherwise, we just remove a character and that was a palindrome and so we return true. So this is time complexity n. So just message anything in the chat and I will show you a similar code, but very similar to what this is that I've already written just to save time. So this is the code. You can just take 1 minute to go over this code. This is pretty self-explanatory, and this is like the pseudocode style of what we have. I have explained to you. So this is a helper function, is palindrome, and if you see what I have done is, I'm just going from left to right and checking if, in case left is equal to right, then I just increment left and decrement right. That's what we did here. We incremented left and decremented right. And in case they are not equal, that means uh, that means one of the either if I remove the left character or if I remove the right character, I can make it a palindrome. So there are several ways to do it. I could have removed directly the character s. This is a little bit different way to do it. So I'm just checking if the string from start to end is a palindrome. So when I do left plus one, so if I remove the character at the left, then I will be left with the string from left plus one to right, and I need to check whether the string from left plus one to right is a palindrome or not. This is very similar. This may look a little different, but it's exactly what we are talking about, and we can modify it to actually make it similar to the this approach that I've mentioned. The time complexity for both is same. Just go over this and let me know if there is any confusion in this. The only benefit in this is that I am only checking for the palindrome from index start to end. So although it still takes order and time, but it has lesser iterations. So if suppose I do what I follow here, that if I by removing left, if I check whether the string is a palindrome or not, then I have to check starting from the starting of the string to the end of the string. But since the first point where we didn't find a matching character was the left and right, that means before that all the characters were matching from the left and the right. So we only need to check the middle part of the string from start to end whether that is a palindrome or not. And so here we just loop over the. This is just a simple function to compute a palindrome from start to end. So the one advantage of using this approach is that it has the same time complexity, but it has a lesser steps. Otherwise, I will be checking from always start is equal to 0 and end is equal to n minus 1. So I can just show you the run this code and how it works. I think it's taking some time to IntelliJ to build, but this should be pretty straightforward. Meanwhile, you can just think over how you will go about solving this question and maybe take a minute or two, and then I will explain the approach and the solution for this. So let's go over this question, and meanwhile, I will, as this thing builds, it should. Okay, so now I think this is the result of running this Q1. So this is true because I can remove C, and by removing C, the string will become ABA, which is a palindrome. So the result is true for this. We can try for other example also. And let's go over this question where we have a set of intervals, start I and end I, and we have to merge all the intervals. So I will try to give an example of this particular case, and we can write test cases for this. So suppose let's go over this some sample test cases for this. So suppose the input is this one. What we have to do is output. So if you see the first interval 1 3 and the second interval 2 6, they overlap because 2 lies between 1 and 3, and so we can merge the first two interval and then the output will become this one. Let's take one more example to understand it more in a better way in case there is some confusion. So suppose the input is this. If you see in this case, if we 1 comma 4 and 2 comma 5 overlap. So if we merge 1 comma 4 and 2 comma 5, it will become 1 comma 5. But 1 comma 5 and 3 comma 6 also overlap. So if we merge them, it will become 1 comma 6. The output should be this. This is another example. And here, for the sake of simplicity, I'm taking it's easier to compare here because the start index of each of this interval is in a sorted order. But in the given question, the index are not sorted order. I will explain an approach to solve this. So if you see even in this input, in the sample input and output, we can easily merge two intervals because the start index of each interval is sorted. If you see 1 to 8, 15 is in ascending order, similarly here 1 to 3. So to actually merge the intervals, so given any two intervals, we can only merge them if one of them lies between the other. And the only way one of them lies between the other is that suppose an interval one is smaller one and interval two is bigger one. That means the interval two must lie between the interval one, and that means the start index of those two must be sorted. So to solve this problem easily, the first step to solve is to sort the intervals in ascending order based on the start index. That's the first step. Now the next step is we start merging the intervals. Just like in this example, what I did was there was 1 comma 3 and 2 comma 6, and I merged these two, and the final interval becomes 1 comma 6. And similarly, in this example, I can merge 1 comma 4 and 2 comma 5, and the interval becomes 1 comma 5. And then again, I can repeatedly merge 1 comma 5 and 3 comma 6 to 1 comma 6. Now let's break these steps down. So since we are merging two intervals, uh, let's start by having a separate list. Let's run over this particular input and see how we can produce this output. So I will explain the logic and then I will just show you the code how to implement that logic in an efficient way. So our initial thing is 1 comma 3. Obviously, don't need to merge anything with 1 comma 3. Now we take the next interval, that is 2 comma 6. And since the elements are sorted, we see whether they actually merge or not. And if you see 1 comma 3 and 2 comma 6, they do overlap. And since they overlap, we merge it, and we're maintaining this. This is a separate list where we have the initial element. It will become 1 comma 6. Now we in our result list we have 1 comma 6, and the next element from the main input list here is 8 comma 10. And when we merge, and then these two don't overlap, and so if we merge, since in the case that these two don't overlap, we simply append the new interval that we have non-overlapping to our resulting list. So our resulting list becomes this. Now, once we have this resulting list, the next piece of interval in the input list is 15, 18. And what we need to do, we only need to compare the current interval that we are iterating on with the last particular interval. Since the list is already sorted by the first start element, this cannot overlap with any other interval except the last interval. Because if it actually overlapped with any of the interval, then that would mean that this particular interval will also overlap. So let's see how. So we only need to check whether this particular interval can merge with this particular interval. If it doesn't merge, that means the 15 lies is greater than the last element in here. If you see in this case, so this is a non-overlapping case. Since 15 is greater than this, then so obviously if we look at the earlier elements of the list, it cannot obviously merge with those. So the idea about this is we only need to check with the last element of the list, and this is a non-overlapping interval. 8 comma 10 doesn't overlaps with this, and so we simply just append this, and that's all. The iteration is complete, and this is our final output. Now let's see how we can apply the same logic to this particular input. So our initial resulting list will just consist of a single element, and then we pick up the second element and see whether the last element of the list, which in this case is the first element, 1 comma, whether they overlap or not. And they do overlap. They overlap because the start element lies between the start and the end element of this list. And once they overlap, we merge them. And by merging them, we get this particular item. Now in our resulting list, we have this, and the next element in the input is 3 comma 6. And if you see, these two also overlap because 3 lies between 1 and 5. And then we just merge 1 comma 5 and 1 comma 6, and then we have 1 comma 6. So this is how the algorithm will work. So idea is to maintain a list, a result list, and initially we can just put the single element, the first element of the list of interval, and then iterate over the array of intervals, and let's write in the more pseudocode style. So if they do overlap, pull out the last element of the result and merge it with the current interval and insert it back into the result list. So We just need to check, and if they don't overlap, then we just append the interval to the result list. And that's all the algorithm. And since this algorithm actually uses sorting, so this takes order and log n time. And the for loop just takes order and time. So combined, it will only take order and log n time. So if there are any queries related to this particular thing, you can just message me in the chat and let me know if there are any queries related to this approach. And I will show you a code which is exactly based on this particular approach, which is this class. So here I've used some, this is exactly the same approach. So if you see here, I'm sorting the intervals and I'm then creating a final output list, which will be actually consisting of all the merged intervals. And then I take the current interval and merge, add that to a list, and then I scan the list of all intervals. And this particular case checks that whether the intervals overlap or not. And if the current end is greater than equal to next begin, this is similar to the this particular case where like these two overlap, where current end, which is 3, is greater than 2. That means the intervals overlap. And if the interval overlap, we basically just take the max of these two. So if you see here also what we when we overlap, what we the final ending part 6 is nothing but the max of 6 and 3. And so we just take the max of this, and this is the new interval that we have, and we just basic current interval, and this is this is doing. This is basically updating the last element of the list. If the intervals don't overlap, in that case, we basically just append the final interval to the list, and that's all. And this is the approach we're taking. And here we are using this lambda function. So array dot sort. This basically takes first element is the interval, which is a double array, 2D array, and it takes a function which specifies how to compare two elements. So this is a lambda function, which means that if A and B are two elements, we use only A0 and B0. That is when zero index is the start element. So we basically compare it using the start element, and that's what actually I wrote it here, that we are basically comparing it using the start element. And rest is all as straightforward as what we did here. And let's try to run it over this sample example. Let's see if the output is correct or not. So if you see in this particular case, 1, comma 3, 2, comma 6, 8, comma 10, the 1, comma 3 and 2, comma 6 overlaps. So they will merge 1, comma 6, 8, comma 10, 15, comma 8. And since we are sorting, so the order should not matter. We can even interchange and this code should still work. Let's run it again. The answer is the same because it doesn't matter the overlapping part. And you can have a look at the code. And anyways, you don't need to save it. Uh, Main part here is like generally when you are actually giving interviews, you should try to use this inbuilt function of Java more and more, because otherwise if you don't know about this sorting function and using these lambdas in this way, then it may take you several lines of code to write this particular function, which can actually take a lot of time. And if you know how to use these lambda functions and other Java 8 features, you can save a lot of time using this. So let me know if you have any queries related to this.